So Hermes has a cluster mode, yes. So Hermes now supports a cluster mode for high availability and durability. And so far, as you know, that we have been working with a single node. Now we can deploy multi-node cluster for Hermes as well. And then the app will connect to that 3-node or 6-node Hermes cluster as a Scylla DB cluster. So as it was already doing that, but now it will see this 3-node or 5-node or 6-node of nodes of Hermes as a Scylla cluster of 3 nodes. And if there's a node failure on Hermes side, the driver, native driver will be smart enough to switch to that new node. Hermes does broadcast the current status of its node's liveliness and everything back to the application, and the driver will automatically handle everything for us. But yes, so I'm going to show you that quick demo of how this works. And also the other important thing is that now we also, because since we are running multi-node cluster, we want to be able to see what is going on with the other nodes of the Hermes. So we don't need to connect to individual nodes to see that. Now, just like the node tool status on Scylla, I added a Hermes status command within Hermes where we can get a very nice information page about the Hermes as a cluster and what exactly is happening, what is doing, for how long has it been online, and things like that. So to help with all of that, I have added a lab environment within Hermes. As you see here under examples lab folder, we have a setup where we basically use Docker Compose to spin up 3 nodes of Scylla cluster. As you see, Scylla 1, Scylla 2, and Scylla 3. And then we got 3 nodes of target clusters. So the Scylla 1 is a source cluster, target is the target cluster, and then you got 3 nodes of Hermes that gets provisioned. They are already configured to connect to these 6 nodes, 3 nodes each for as a source and target cluster. And then we also get an app container that runs Python code to try and push some traffic onto the Hermes nodes or Hermes as a cluster. So we're going to see that in action. So what I'm going to do is I'm going to connect to this container. Let me increase the size a little bit and let's go to full screen. Um, so I'm already connected to the container, and if I do a listing, we can see that there's a go.sh which is already set up to for you to run. You don't need to worry about anything, just do go.sh and then it will start pushing traffic to the Hermes cluster. But I'm gonna run with start. Um, start.sh. So the first argument it takes is the number of threads that each Hermes will get, right? So each node of Hermes will get, so 3 threads, or we can say 2 threads because there are 2 eCPUs, so let's go with 2 threads. And then the traffic, the throughput that we want to target, I'm going to go with 100 because it's a local setup and I don't want to go too high. And then of course the last one is the consistency level, local quorum. So Hermes will push this local quorum consistency level as a pass-through value to the Scylla nodes, backend Scylla nodes. So once you run it, we can see that the two threads are already running. You see T0 and T1, 2 threads are running, and give it a minute. We can see that the driver is able to see the 3 nodes of Hermes. You see here 1, 2, and 3, these 3 lines. So these 3 lines are the 3 endpoints. So it's live on those 3 nodes. And yeah, and we can see that these are the IPs for the Hermes nodes, is connecting to the 9042 port and all that stuff. So everything looks good. I'm going to open up another session and I'm going to push this to, let's push this to auto tiling, and then this guy will also auto tile on the right side. And I'm going to do I'm going to connect to a Hermes, the first node of Hermes in the cluster, and I'm connected right now. So if I do the listing here, so how this container is set up, so under the app folder we got the Hermes app deployed, which is currently running, and the dual writes is happening through this code. So now we can see that these threads are actually pushing some read and write traffic, and it's able to talk to Hermes and then push some traffic. Now, how do I know that Hermes is actually getting any traffic at all, right? So how do we do that? There's as I mentioned, there's a status command. So Scylla Hermes status. If I run that, it gives us a very nice looking output of the current Hermes nodes. So there are three nodes, and they all of them are live. So this self being that this node dot 21 is actually the one that we are connected to. So this is the self, and then we got two siblings, and they are all live. And then we also see the status of our backend cluster, right? At a very high level, that there are three nodes on origin side, three nodes on target side, and then they both have two shards each. Of course, because I have a 16 CPU machine laptop, so I'm giving two CPUs per container, and then each of them are connected two by two, right? So they get full connectivity over there. And then another nice thing is that on the cluster side, origin and target side, we also get a throughput value, that what's the throughput happening currently, and how many reads per second, how many writes per second are happening. And then we also see some read and write latency from the Hermes's point of view. So now this is the one-time status, but how do I get a consistent status? So I can get it through status interval, and then we define the interval in seconds. So I'm going to use 2 seconds interval. So now this guy is going to keep refreshing or keep updating this page and gives us live number, as you see here. So we are getting somewhere around 64, 65 reads and writes per second, or 70, so around that. So because this is a very small setup, the numbers are not exactly identical, but if we are getting some traffic here. And then you see on the target side, we are not getting any reads, which is expected, because Hermes will only do read and write on the source cluster, which is origin, and on the target side, it's only going to push the writes. So that's just to keep them in sync. And then we also see some latency number, which is really very, 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 very small in microseconds. All right, so now let's do some disaster testing. So I'm going to put this window down here, and then I'm going to resize this a little bit so that we get a full picture from the previous window. Now if I do container stop Hermes 2 and Hermes 3. So now I'm going to, out of the three Hermes nodes over here that you see here, I'm stopping two of them, just to see what happens to the application side. And of course, what happens to this one, the live status, and also what happens to the throughput. Now you see it's going somewhere around 75 or 65 reads and writes per second. The nodes are reporting as down, and we can see, so the two nodes are down, which is awesome, as expected. And then we can see now, since there's only one Hermes node left, that one single Hermes node is actually pushing to 200 reads and 200 writes. So because the application is still pushing the same amount of traffic, so the application doesn't know that I got three nodes that are not available anymore. So the app code I have written in such a way that it's always going to target that many transactions per second or operations per second, and that's what's happening here. So now the last remaining Hermes node is actually doing the maximum that it can do, 200 operations per second. And then we can also see the driver, the application driver is only seeing one Hermes or one endpoint, which is correct. If similarly, if I start these nodes up, the status gets updated immediately, and then we will see that this traffic immediately reroutes or application reroutes this traffic to the remaining available two extra new nodes. And that is why the throughput on this particular Hermes 1, which is this guy, now drops back to the typical level, like 60 to 70 reads and writes per second, which is awesome. So now what happens if I have backend failures? Let's do that. Stop Scylla 1, and I'm going to do target. Let's say we want to stop one node from the target cluster and one node from the source cluster. Keep an eye on this window and also the throughput window, and we can see that from the origin side, the first node down, and on the target side, the second node is down, and everything is still running as per normal, like 60 to 75 reads and writes happening. Hermes or this application is still seeing 3 endpoints, which is true because it's connecting to Hermes, not Scylla backend directly. Um, Now, what happens if I start this containers backup? Of course, it will start up, the status will get updated, and everything will be running as per normal. Like it is BAU, business as usual, no problem at all. So I don't get any operation failed here or validation failed or retry. So there's nothing like that happening on the application side because the driver is doing all the work for us. And Hermes is also routing traffic accordingly. It's able to re-establish connectivity to the backend nodes immediately as soon as they are available without losing any transactions. Now, what happens because we are running quorum? What happens if I down 2 nodes from the same source cluster? Scylla 2. Let's say we lost these 2 nodes. This is where things will start to fail. So it's doing a retry, internal retry mechanism within the app. So it's a driver level retrying and it's not able to do anything because obviously the quorum is failing, because you see here local quorum error messages are coming up and then it's not able to do anything. And what I need to do is quickly start, let's say I start one of these nodes. So as soon as the quorum is satisfied, I expect this app to resume and yeah, resume successfully. All right, there you go. Yeah. So as soon as the node went back or came back online successfully, the application started working without issues, and we still have 1 node down on the source cluster. And I'm going to start that other node as well so that we have a full live cluster. Okay, give it a while. Okay, awesome. So the node is started. The status is going to get updated anytime now. There you go. So now let's do one more thing. I'm going to stop. Yeah, Hermes 1, Hermes 2, Hermes 3, and then I'm also going to drop Scylla 1 and target 3 maybe, right? So let's do that. So we have a very serious disaster, multiple node failure on Hermes side, 1 node lost on Scylla side, 1 node lost on the target side, target Scylla side. So we got a disaster here. But the great thing here is that with all the nice things and stability and durability and high availability built into Hermes and the driver, of course, the application continues working without, as if nothing happened. And then we are still getting 200 operations per second for reads and writes. As you see here, it only sees 1 Hermes node, but everything is working. Two Scylla side nodes are down, 1 from the source, 1 from the target, but nothing fails. All right, so let it run this way. Now, as you know that we got some operation failures here, like 23 failed operations happened. So what I want to do next is I'll connect to I'll connect to the Hermes 1 node again, and over here under var, let me increase the size a little bit. Var log Scylla Hermes. So there's a var log Hermes folder. Over there, we will see some data under failed transaction as failed transaction logs, right? So this is updated today. This actually is a persistent folder on my local, and that's why we see some data sitting here from yesterday, 5th of August, and some data sitting here as of today. So let's cat this file. Cat failed transaction log. So we got a lot of data. What actually is this showing us is is individual items or individual data that didn't make it to the source cluster or the target cluster. So it's, if you see here, we are seeing a timestamp, and then we are seeing the actual block of data that failed to reach, right? This particular packet failed to reach the cluster, if you see here. So all these things are the actual SQL frames that did not reach the target cluster, and that is where um, what we have in Hermes is that we have this ability to replay these failed transaction whenever we want to, and Hermes will replay this transaction using the same timestamp that we see here. So this will be using like the actual right timestamp of the failed transaction, and it will replay them in the same order, so that Scylla will handle this automatically in a proper manner. All right. So there you go. So we do have this full audit logs where we can replay those failed transactions whenever there's a failure, and then of course we got full availability and full high availability features where we get multiple nodes down and everything still works. So let me start them up. There you go. And then they will eventually, like within a few seconds, they will start to show like normal status, and then our throughput will go back to like individual nodes doing less amount of work, because now we got 3 workers or 3 Hermes here. There you go. And then the driver also picks up that there are 3 nodes that are now available. All right, yeah. So that's all I wanted to share with you. Hope you'll have fun testing this out. Now you have a local lab where you can spin up this environment very quickly and do whatever test you want to do. You can change the application code, do your own schema setup, and test it out. It's much better now.